Welcome back. In our last video, we discussed about the inverter efficiency, resistive and inductive load up to the state of charge here. So today we are going to continue from where we stopped. Our panel performance ratio. So the panel performance ratio is the amount of rated power that is usable from your panel. Let's take, for example, let's say this is your panel and is rated for 1000 watts. The panel performance ratio is telling you the amount of wattage that you can continuously draw from this panel. Let's say, for example, the panel performance ratio of this panel is around 60 to 65%. It means out of this 1000 watts, what you can draw from this panel is going to be 600 watts and 650 watts. So some of the factors that affect this panel performance ratio based on region. If you are in the north side, the sun there has high intensity as compared to those from the south. So for people in the north, they have higher performance ratio. Also, maybe when you mount your panel, because of the direction, because of shading, it is affecting the panel to perform at its peak performance ratio. That's why when you are sizing your panel, you must take this figure into consideration so that you know undersize your panel. It's rated around 60 to 65%. So when next you are sizing your panel, 1000 watts is not what you calculate as exact figure for your panel. Rather, it's going to be about around 600 to 650 watts based on your location and based on the weather condition. Number 6, we have the peak sun hours. The peak sun hours is the time of the day where the sun is at the peak. Nigeria is about, you can check Google, that the peak sun hours in my area. So in Nigeria is about 5 hours. It means from 8 a.m. in the morning that the sun is coming out up to like 5 p.m. in the evening is only 5 hours that the sun is at the peak. When we are calculating, when we are sizing our battery, we are going to take this into consideration and you see how it's being calculated. So when sizing your battery, you have and your panel, you have to consider your peak sun hours because it's really going to help you. Because if you size your inverter based on 8 o'clock to 5 o'clock, it means there are some days where the weather condition is very bad. So you are not going to be sizing it correctly. So you have to consider the peak sun hours. In Nigeria, is about 4 to 5 hours. But to be on the safer side, if you are sizing yours, you can use between 2.5 to 3.5 hours. At number 7, we have the inverter idle power consumption. When your inverter is sitting down, it's doing some work, it's converting AC to this. Even if it's not doing any work, there are some power that is being lost. It's very, very minimal. It's very, very small. Even if you keep your inverter maybe for like 20 days, the inverter efficiency will not drain up the battery. But because you want to size your inverter properly, you have to take your inverter idle power consumption into consideration. Number 8, we have days of autonomy. It's the number of days you want your battery to be powering your loads without connecting to the panel or to the grid. Let's say you charge your battery fully now and you want it to be working for you for like 48 hours, that's 2 days, without it charging. So those days that you want it to be running are called the days of autonomy. Understanding these 8 factors that we have stated is going to help you to accurately size your battery, size your inverter, and size your panel. So in our next video, we'll be explaining, or we'll take a real life sample on how this factor comes into play. We'll see you on the next one.